Assalamu alaikum level metric students, this is your teacher Fayyaz Ahmed. Welcome to the new session of 2021 and 22. This session of physics will start with a chapter that is basically waves and sound. And in today's lecture we are going to discuss the four main topics and first four topics of this chapter, which are introduction to waves. Then we'll discuss that what is an oscillation, how it is produced, and then simple harmonic motion. What is simple harmonic motion? It has a short form of SHM. And what is the example of simple harmonic motion? What are the examples? One of the examples of the simple harmonic motion is simple pendulum. We will discuss the simple pendulum as an example of simple harmonic motion. So our first topic will be the introduction to waves. By answering these simple questions, we can easily understand that what is a wave and how it is produced and what are the different functions of wave. The wave is a very interesting topic and we can observe the waves in our daily life. So the question number one is that how sound is produced. So basically sound is produced due to the rarefactions and compressions of the air particles, and it travels from one point to another point. So you can generally describe a wave as the disturbance of a medium which travels from one point to another point. So similarly, sound is produced by disturbing the medium of air. The particles of air are disturbed at one point, and this disturbance just travels to another point, and hence sound travels from one point to another. So sound is also a type of a wave. Now the next is basically the light. Light is a wave which do not need any medium to transfer. It can transfer without any medium. So light are basically the electromagnetic waves. Of course, if we are talking about the sun, so basically the light of the sun originates from the sun and it reaches to our earth directly from there. So light is one kind of a wave as well. Third is why we place TV antennas at the top of our homes. So basically the TV antennas just brought the TV signals, which are basically the radio waves. Radio waves possess the information of video and audio. So basically this is also a type of a wave. So we can see many types of waves all around us in our daily life. So the second topic is basically the oscillations. In order to understand the oscillations, it is important to discuss the oscillatory motion, because the oscillations are the result of the oscillatory motion, which is one example of periodic motion. So what is a periodic motion? A periodic motion is defined as a motion which repeats itself in regular interval of time. So basically, for example, if the wave of the motion or if the behavior of the motion, it is continued after the equal interval of time or equal chunks of time. For example, there is a pattern of movement of back and forth motion after every 2 seconds. So you can say that this motion is quite similar over the large instant of time, and it is repeating itself. So any motion which is repeating itself after the equal interval of time is known as the periodic motion. So oscillatory motion or vibratory motion can be defined as the back and forth motion of the object when it is moving forward and backward. I have also given you the example of the oscillatory motion. For example, if there is a spring and if we have connected a metallic bob with that spring as shown in the figure like this. So this is the spring and this is a horizontal surface, and on that horizontal surface a metallic bob is connected with this spring. So if we just try to just pull this metallic bob towards the right hand side, so what will happen? The spring will get expanded, but when we leave this one, so the bob will get back. So the forward and backward motion starts. This forward and backward motion of this metallic bob is known as oscillatory motion, and the one complete round trip, for example, if a body just goes from here then come back here, So this forward and backward motion is known as the oscillation. So oscillation is defined as one complete round trip of a body in its respective motion. Now our next topic number 3, is basically the simple harmonic motion. Now what is a simple harmonic motion? The motion of an object or any mass which is connected by a spring is known as simple harmonic motion. You can also observe the simple harmonic motion as shown in the figure. Here is one bob which is connected by a spring. The motion of this bob to and fro motion is basically called as simple harmonic motion. So it might be a surprise for you that why it is called simple and why it is called harmonic. It is only called simple because it is just a vibratory motion, to and fro motion, and it is called a harmonic motion because it just repeats itself after the equal interval of time. There will be a constant vibrations, constant oscillations. That is why it is called simple harmonic motion. Now there is another definition of simple harmonic motion: the motion in which the acceleration is directly proportional to the extension or displacement is called simple harmonic motion. Now what is the explanation of how do we explain this definition? In order to explain this definition, you have to focus on this figure. In this figure it is shown that this spring is present at its equilibrium state and we have not disturbed it yet. But whenever we will expand it or we will apply the force towards the right, the spring will get expanded, and whenever we just leave it, there will be a restoring force opposite to it. Now this restoring force means that wherever there is force, there is acceleration. So the more we are expanding this object, the more will be the force, and the more will be the force, the more will be the acceleration, according to the Newton's second law of motion, that whenever a mass is applied with the force, acceleration is produced, which is directly proportional to the force which is applied on it. So basically, whenever the force is applied, the acceleration will produce. The more force will be applied, more acceleration will be produced. So the elastic restoring force is in the opposite direction. So basically, in the simple harmonic motion, the acceleration is directly proportional to extension, because if we are expanding it more, the more force will be applied and the more acceleration will be produced. So basically, Hooke's law is the best explanation of the simple harmonic motion. We have already discussed Hooke's law in chapter number 10, which is the properties of matter. So basically, what is the mathematical equation of the Hooke's law? F is equals to kx. But always keep in your mind that whenever we are discussing about the simple harmonic motion, we are not just referring to the extension of the object which is connected by a spring. Instead, we are more focused on the restoring force, the elastic restoring force. Now what is the elastic restoring force? When this spring is expanded, what will happen? The spring will apply the force on this mass to come back to its original position, so that the mass will come back to its original position. Now this opposite force is basically the elastic restoring force, and that is why we place this negative sign over here, because the extension is towards the right and elastic restoring force is towards the left. This opposite direction of extension or displacement and the force, due to this opposition, we just place the negative sign in the mathematical relation of the Hooke's law. So due to the elastic restoring force, which is quite opposite to the extension, we just place negative sign in the Hooke's law. So a very important topic regarding the simple harmonic motion is the definition of the simple harmonic motion. And the definition of simple harmonic motion, as we have already discussed, is the acceleration is directly proportional to displacement in the simple harmonic motion. So a motion in which the acceleration is directly proportional to the displacement, which means if the displacement is increased, the acceleration will also be increased, is known as simple harmonic motion. So in order to prove this statement, we will just use the two laws which easily explains the simple harmonic motion. So the first law that we have already discussed is the Hooke's law, which is F is equals to minus kx. This F is the elastic restoring force, this k is the spring constant, and this x is the displacement of the object. Similarly, there is Newton's second law's equation, F is equals to ma. This F is the force, elastic restoring force, and this m is the mass of the object. This a is the acceleration produced in the object when elastic restoring force is applied on it. So basically what we will do, we will just prove this statement by just comparing these two equations. So F, you can see that on the left hand side of these two equations there is one F which is quite common. So we will compare these two equations. So the right hand side of this equation is minus kx. We will equate it with the right hand side portion of this equation, which is ma. Now you can just write it otherwise as well. For example, if you want to write it does not matter, we can shift these two easily. Now we have to prove acceleration which is directly proportional to extension or displacement. So we will just divide this m on the other side. It will become now, as you know that this k and this m both are constant. This m is basically the mass of the object, this and this k is the spring constant. So basically these two are constant, so we will just neglect this one and we will just neglect the equal to sign as well, and instead of these two we will place the proportional sign. So as you know that whenever we remove the proportionality sign, we place two things, equal to and constant. Now we are doing the opposite thing. We are just removing the equal to and constant. So whenever the equal to and constant are removed, instead of it proportionality sign comes. So k upon m, which was constant, and is equal to, we have removed these two things and instead of it we have placed proportionality sign. So here we have proved that acceleration is proportional to the displacement or extension, and this is the proof of this statement that acceleration is directly proportional to the displacement. So this is the definition of simple harmonic motion and its proof. So the last topic of today's lecture is basically the examples of simple harmonic motion. So here we have one example, and that is basically a simple pendulum. So what is a simple pendulum? So simple pendulum can be easily formed by just connecting one metallic bob or any mass by a inextensible and weightless string. Now this is an inextensible and it has almost no weight. This is one string and the mass is connected with it. Now how to just produce the simple harmonic motion when a mass is attached with the string which is supported by a support at the top. Now in order to produce the simple harmonic motion, what we'll do, we will just push this bob towards it, any one of the sides. Let's say we are just pushing this, holding this and then pushing this bob towards the position 2. So when we will just move this bob from position 1 to position 2, what will happen that as it is covering some sort of height from the horizontal surface, so basically gravity will pull it back. So when gravity will pull it back, so it will come back and then it will once again go through its equilibrium position, its mean position, and it will continue its swing up till the position number 4. So whenever we are disturbing or moving this point, this bob from point 1 to 2, the bob will come back to the mean position and then it will complete its swing. So this complete motion which is quite a to and fro motion is known as simple harmonic motion. Now simple pendulum is simple. Why? Because there is one string and there is a metallic bob. Whenever we want to just produce simple harmonic motion, we have to do nothing but to just move this bob towards either of its side, and it will continue to swing and produce the simple harmonic motion, and it will produce the different oscillations. Now it is very important to discuss the time period of the oscillation. In this case, the time period of the oscillation, first of all let me tell you that what is a time period. A time period is basically a time required to complete one swing of this metallic bob. So whenever this metallic bob completes its one swing, this is known as its time period, and it is equals to T is equals to 2 pi radical L upon G, whereas this L is the length of the string and this G is the gravity which is affected on this metallic bob. So this is it about today's lecture. Thank you very much and Allah Hafiz.